This session is about the cube roots of unity. Now, if you want to do this concept, you must know the nth root of any complex number concept. And this is I have covered in my earlier video, which is if I have a complex number which is given in the form z raised to n is r cis theta, then z is possibly r to the power 1 by n cis 2 pi k plus theta by n. I have explained pretty well in that what exactly and how 2 pi k concept comes in picture. So this you can remember as a formula or key concept for any nth root. So just taking on from here, let's say if you're asked to find out the cube roots of 1. Now cube roots of 1, when you simply see that, I possibly know that one of the answer is 1. Okay, cube root of 1, everyone knows is 1. But because it is, let's say, cubic polynomial or cubic equation, I should have the other two roots as well. So how do we do this? Now, as you know that whenever you're finding out the nth root of any complex number, you always should write down the given answer in r cis theta form. So whenever you have, let's say, z cube is 1, I can write down this 1 as r cis theta form. So 1 has, if I look at where is the position of 1, so if you simply see 1 is a complex number along real axis with length of 1, and its argument is also 0. So this is simple observation about the complex number 1. So I mean, 1 can be written as complex as well as real. So that's what I'm saying, that 1 is a complex number that can be written as 1 cis 0. Now 1 cis 0, here 1 is the modulus, you can see 1 is your modulus and 0 is your argument. Now obviously I'm going to apply this formula. So z is going to become 1 to the power 1/3 and cis 2 pi k plus 0 over 3. So this is your general formula for finding the nth root of 1. So what we do is now we're going to put, so cube root of 1. So now what I'm going to do is I'm going to put different k values. So I'm going to take k as 0, 1, and 2. As I stated in my earlier video, you take, if there are, like, let's say 3 roots, you take k as 0, 1, and 2. If you're finding 4th root, you take 0, 1, 2, and 3, and so on. And obviously I'm not talking about negative arguments. So for that, you can go backwards and like take negative k values as well. But that's something which you don't really want in this basic question. So if I take k as 0, what I get is, I get the first answer as cis 0. If I put k, these values out here, so you can simply see I get cis 0, which is obviously 1. How do we know that? In simple language, I can write down this as cos 0 plus I sine 0. Now, my other complex numbers, so cos 0 is 1 here, and sine 0 is 0. So this is going to be 1. Now, when you talk about the other complex numbers, so you take k as 1, I get cis 2 pi over 3, which is cos 2 pi plus I sine 2 pi. So this is your second complex number, second root of the cube root of 1. Now, when you find out cos 2 pi by 3, cos 2 pi by 3 simply here. So this ratio is basically -half, and sine is √3/2. So just to explain, this is where the complex number is in second quadrant. So cos 2 pi by 3 is -half, which is same as cos 60 to be very honest, and you take negative because in second quadrant. And so is your third complex number. Now you put k as 2, you get cis 4 pi by 3. Now what is cis 4 pi by 3? Obviously it is cos 4 pi by 3, cos 4 pi by 3 plus I sine 4 pi by 3. So I sine 4 pi by 3. So whenever you're finding out the value for cos 4 pi by 3 plus I sine 4 pi by 3, cos 4 pi by 3, if you see, it's in quadrant number 3, which is 4 times 60, which is like 240 degrees approximately. So which is here, which is 60 degrees. So you can find out. So both the ratios are going to be negative, sine as well as cos, because it's in quadrant number 3. So that's why it is cos 60, but it's negative, and cos sine 60, that's your negative ones again, because in quadrant number 3. So eventually, just to summarize, we got 3 roots. Number 1 is what this, number 2 is this, and number 3 is this. So what are the unique properties about these roots? So in IB, there are questions that cover up basically the different types of the indices properties about the nth root. So let's talk about the first indices property. So now what I talk is when I take the value, the first root as, let's say, omega or w, what happens is that if I square this, when I square this negative half plus root 3 by 2 I, you are going to get this. So that's why instead of taking some other variable, I take this as omega square. Okay, so now another interesting property. So this is, you can verify, obviously you can expand it and see whether it's happening or not. But when you add up these 3 roots, now when you see that 1 plus omega square, it's going to be 0. Because if you simply see 1 minus half is 0. And then 0 plus root 3 by 2 I minus root 3 by 2 I. The imaginary parts, if you add, it's 0. So that's why this is your one of the most important property, which is 1 plus omega square is 0. Now you can also use the formula omega cube as it is 1, because omega is a cube root of unity here. So it must fulfill the equation. In place of z, I'm taking omega. I can take just omega one side, okay? So now if you factor out, it will be omega minus 1, omega square plus omega plus 1. Now because you know that omega is a complex number in this case, if they state, because that's what exactly you're finding, the complex part. So this is your part that has to be 0. So that's why there's another way to do this, because lots of times you're asked to prove these kind of questions. Lots of times you'll be getting the 7th root of unity and all. So in that case, like you might do this like this. So omega raised to 7, it is a different question, so don't get confused with this. So if, for example, if it is omega raised to 7 equals to 1, then I can take omega to the power 7 minus 1 as omega minus 1, factor it out, omega to the power 6, omega to the power 5, and up till 1. So in that case, they might ask you to prove, oh, okay, this is 0, show that this is 0. Because omega is a complex number, this part, omega can't be 1, so this must be 0. So that's how you find out the complex roots of like unity. Okay, now coming back to the properties. Now another thing that is very interesting to discuss is omega to the power 5. Like let's say if you have omega to the power 5, I can write down as omega cubed times omega squared. Because you know omega is a cube root of unity, so if I cube it, I get the answer as 1. So you can simplify the questions like this. So this is the concept, key concept about the cube roots of unity. Now I'm going to take you through one of the IB questions in the next video. So just make sure you watch that as well for your better clarity. Thank you.